Welcome. My name is Jin Kim from KMYUNG University. So today, I'd like to welcome to KF Korea workshop. I'm very happy to take this session for foreign people living in South Korea. I heard I've heard you can speak Korean, but yeah. Today we will talk about new technologies related to so-called fourth industrial revolution. As you know, South Korea is a very small country, lack of natural resources. So we have been focused on developing human resources, and we teach how to apply the technology to real industry. For this session, I invited two professors. So let's start the first topic. So first topic is blockchain. So for this topic, I invited Professor Sejin Park from KMYUNG University. So he's working in the Department of Computer Science and Computer Engineering. Now, no, as you can see his face, he's a little bit sick. But he didn't give up this session. So while he's making his presentation, maybe, unfortunately he may leave. And I'd like to ask you to excuse him. Thank you. So Professor Park, you ready? If you're ready, you
yes, I'm ready. May I share my desktop?
So you can share your slide.
Hast du schon present geschrieben?
Yes. All right.
Present geschrieben.
Okay, can you see my desktop? Can you hear me?
Yeah, you can do.
Yes.
Okay. Thank you for introducing me. I am Sejin Park from KMYUNG University. So today I'm going to talk about the understanding blockchain technology. So briefly introduce myself to you. So I am currently assistant professor in KMYUNG University, and I got my PhD degree in post-tech in 2016. And at that time, I was working on server virtualization and storage system. And after that, I worked in SK Telecom, and I developed a big data analysis engine. And then I joined the KMYUNG University Department of the Computer Engineering, and currently I give lecture of operating system and database and data structures. And now I have my own laboratory named the System Software Laboratory. Currently, as of now, I have 6 researchers, and my research topics are blockchain technology and AI-based system performance optimization and AI-based music composition. So today I'll give you about blockchain technology. First, I will explain the first generation blockchain named Bitcoin. And then I will briefly say about the characteristics of the blockchain system. And then I will talk about the second generation blockchain named Ethereum. And finally, I will briefly talk about the NFT. Currently, it is really popular in metaverse and lots of art. And I will wrap up this slide. So now I start. So on October 31st and 2008, hundreds of people, including cryptographic experts around the world, received this mail. Right side of this slide include the white paper link. So as you can see, the sender of this mail is Satoshi Nakamoto, who is well known for the main developer of the Bitcoin system. And at that time, unfortunately, the academic community was not interested. So on January 3rd, 2009, he created his Genesis blog on his computer. So in this word, the Genesis block means the first block in a blockchain. So which means that the current blockchain is started on 2009, January 3rd. So according to the record, in May 2010, a programmer ordered 30,000 pizzas at 10,000 Bitcoin. This is the first recorded Bitcoin-based payment. So in blockchain, there are 4 important characteristics: decentralization, transparency, immutability, and availability. So in decentralization, currently everything is stored in the central server, like a bank system and web server. But in blockchain, it is not allowed. Everything is distributed in the whole participant in the network. And the participants directly managed by the verification on approval and agreement processes. And transparency. So the reason why blockchain is popular, it is transparency. All participants in the network can see the whole data. The blocks are data in blockchain system. And immutability. So once a block is created, then it is not easy to modify. And finally, the availability. So blockchain has high availability because all of the blocks are stored across all participants. So this means that if one knows miss or lose their blockchain, then it can be easily recovered because other participants has the same copy of the blockchain. So these 4 characteristics are really important for blockchain system, but I think it is not easy to understand. So I'll explain a little bit easier. So it's easily a blockchain is an immutable distributed database. So blockchain is a chain of blocks. In this case, block is a data storage, like a database. And chain means append-only chain, which connects continuously. And because of this chain, the block is immutable. The immutability is achieved by the hash algorithm, which will be explained in the next slide. And decentralization, as I explained, all data, all blocks are stored across all participants in the network. So as you can see in this picture, there are 4 blocks. The 4 blocks are chained. So when a block is chained in the blockchain, then it cannot be modified. But when it is created, but not in the chain, then the block can be modified. So as I said, a blockchain is a small read-only database because data can be stored in a block. So in a conventional blockchain like Bitcoin, a transaction that sends money from A to B is a data. And also, general data storing is available like ID card and certificates or driver's license and something like that kind of licenses or certificate can be stored, which means that we can use it in our real life. Technically, a block is composed of block header and block data. In the block header, there are some kind of metadata like hash and timestamp. And the data has this general data or these transactions. So I will explain the immutability, how to achieve the immutability. It is based on the hash technique. So a Bitcoin is SHA-256 hash function. So I think a hash function can be slightly hard, difficult word, but it is really similar with the function when you learn the mathematics when you are in the school. So if you put some value as an input, then you will get the same output. So the same input, the same output is the basic mechanism of the hash function. So I said each blocks are chained, and this chain makes a blockchain. The chaining is not a real chain. The chaining is achieved by the hash value. This hash values is a brief data set of this block. So, for example, if this block has 100 values, and then 100 values are put into this hash function, and then this hash function will make a small digest of these blocks. And the small digest is stored in the next block. So this block can be modified because if this block is modified, then the hash value will be different. So we can achieve the immutability. And if you make a new block, then the block cannot be modified. It can be modified because it does not have any hash value. And I will talk about the decentralization. So the distributed nodes store blockchain safely without a central server. But we can have a question like that. Why do we need a blockchain? Because I think it is enough to use database when we store some data, not in the blockchain. So I will explain the reason why we need this blockchain. So in blockchain system, before the blockchain system, everything is stored in the central server. So in this page, I will explain some problems of the centralized server-based system. So centralized server-based system assumes that this system is always trusted and safe. This is an assumption. So what if central server fails? And what if the central server is hacked? Or what if the central server intentionally manipulates by the data, maybe by the malicious administrator? So we can lose our data, or we can be our data can be modified without our action. So sometimes we can see a banking system can be hacked, or a banking system can be broken out of service because this is a centralized server-based system. And also current banking system has some cons, like I will explain some bad thing of the current banking system. So this is a basic process of sending money from user A to user C to user D. So first, user C requests the bank to send the money, and the bank deducts the amount of the money from the account of the user C, and the bank deducts the amount of the service fee from the account of user C. and the bank finally adds the amount of the money to user D, it is only working in the internal system in the bank. So in this case, just think about this case. I send my money to my friend, but the bank system, they charged our service fee. So can't we get rid of this bank? If there is no bank, then we don't need to pay the service fee. So let's think about how to get rid of the bank. So how does user C send money to user D without a bank? So just guess in this figure. So if C and D can meet, then they can send their money without any problem. We then hand over the money. Then how do you transfer money without seeing each other? So this is a difficult problem. So in this case, we can have the same ledgers, the same account. So maybe they can talk with the telephone and they can modify their own accounts. Like I send you some money. But in this case, however, if the same ledgers are different, in this case, a dispute has occurred. So we need a bank. Since it is a transaction between two people, if one side manipulates intentionally, then it is difficult what the original data is. So to solve this problem, one of the possible idea is everyone shares their accounts like this. So in this case, user A and user B shares their own accounts only. And also user C and user D shares their account. However, if they share all of the accounts at the same time, then the original data can be stored safely. So even if one user manipulates the data, the original record is preserved in some user's node. So if we make a system that stores all users' account, then we don't need any bank. So in this case, so we will propagate all of the transactions into all users in the network. So we call it decentralized system, distributed storing of transactions. But in this case, there can be a possibility to have some malicious users try. Like, what if a malicious user tries to distribute a false transaction? For example, if the user has only 10 coin, but in this case, the user C can send 1 million coin to other users. So in this case, we need a verification process. So each transactions is verified by comparing it with ledgers he or she has. For example, because all users has known that the user C has only 10 coins, then it is not possible to send 1 million coin from user C to others. So if the user C send a transaction that contains send money from user C to user D with 1 million coin, this is a false. So this kind of transaction can be verified by each user's ledgers. But there is an important problem named the double spending problem. So if you send a false transaction that succeeds in a verification, so this means that if user C makes this kind of transaction that is true, that can be verified, like user A has their own account, user A can verify this transaction and this transaction is true because user C has 10 coins, and according to this transaction, user C will be sent money to user A, 10 coin. So this is true. But user C make a transaction to user B and he send money 10 coin. And also this is also true because according to the ledger in user B, the user C has 10 coins. So this transaction is true. In this case, the same. So although he has only 10 coin, but according to these transactions, he can use 30 coins at the same time. So we call it a double spending problem. So to solve this problem, we need a consensus. So all the transactions generated from the users, some users should be stored at the same time, and the data should be consensus state. So each transactional unit consensus overhead too large. So in blockchain system, a block unit consensus is required. So in consensus algorithm, there are two main algorithms are popular. The first one is POW, proof of work. So the person who solves a password generate a block, like Bitcoin or Ethereum. We call it a miner. And POS, proof of stake, the person who has lots of coins will generate a block. In POS system, it is faster than POW, and also it consumes lower energy. The energy consumption by Bitcoin blockchain is really a big problem in the world. According to the annual power consumption in 2018, it is 39th place in the world, the Bitcoin mining here. So it is really important problem. Okay, and currently we use the Ethereum. We call it a second generation blockchain because it supports smart contract. A smart contract is a simple code. So user can run an application on top of the blockchain. This makes we can send the money without our interaction. Like sending money can be achieved by a code. And we can also make many applications on top of the blockchain. So the Ethereum is really important in terms of smart contract. Okay, this is my final talk, NFT. Now, currently NFT is really popular. So NFT is non-fungible token. So fungible token is like Bitcoin or Ether. The same value and function and one-to-one exchange for each token are possible. So we can exchange tokens like Bitcoin's transfer, Ether transfer, but the NFT is different. Each token has a unique value. There are no identical item, the only one thing. And also it is permanently stored with encrypted transaction in the blockchain, which guarantees its uniqueness. As I said, the blockchain has immutability. So once an NFT is stored in the blockchain, it is guaranteed the uniqueness. And NFT is mainly implemented as an Ethereum-based token. So now investment in NFT-based digital arts begins. Like this art made by people. The title of this art is Every Day is the First 5,000 Days. So as you can see, it is really expensive. But this is a digital file generated with the NFT technology. So how can digital artworks be included in the NFT? If you have some digital artwork, then you can also upload your artwork into the blockchain as an NFT. If you follow this direction, the first, create an account on the NFT exchange, and then register your art. Register means upload, and it will create a unique information and current timestamp, and that will be a metadata for your artwork. And the metadata is included in the token, and the token is issued. Then others can verify the uniqueness of the digital works because it is stored in the blockchain. In the near future, various assets in some metaverse, like real estate on items based on this NFT. And a method to verify various assets in the digital world. So blockchain, NFT, metaverse, everything's are connected. So this is my last slide. So I wrap up my talk today. First, I explained what the first generation of the blockchain, and then I explained the 4 characteristics of the blockchain: the decentralization, transparency, immutability, and availability. And I explained some consensus algorithms and the 2nd generation Ethereum. And finally, I said about the NFT. So thank you for listening today. This is the end of my talk.
Thank you, Professor Park. Even though you feel pain, Okay. So can you? So everybody, can you mute? So we hear some noise from. Okay, thank you. So are you all right now, Professor Park?
I'm not sure.
So you heard about the blockchain technology. So I understand everybody knows about Bitcoin. Bitcoin is the main application using blockchain technology. So as I understand, every information is connected. So if you want to modify information, that you have to all of the rest of the information modify. You have to modify.
You're right. Yes,
So
correct.
it's very very difficult to change. And so it can so immune up. So it is really immune, right?
Yes.
So that's my understanding about blockchain. So if you guys have any questions, then it's the time for you to raise your voice. No?
I have a question, please.
Thank you.
Yes.
Yes.
Dr. Park, thank you so much for your lecture today. You mentioned the huge amount of energy that is required to operate cryptocurrency. And Bitcoin, you said, consumes the most energy at the moment with 39%. At what point do you think it will no longer be financially viable? And how do you hypothesize that companies like Bitcoin can adapt their mining methods to reduce their energy consumption?
Yes, the first version of the blockchain, they use the POW-based consensus algorithm. The reason why it consumes lots of energy is it needs to calculate some puzzle, and the calculation requires lots of computing power. So they use GPUs and a cluster of GPUs, which consumes lots of energy. So in the first generation of the Ethereum used the POW-based consensus algorithm. But maybe you'll see soon the second version of the Ethereum will use the POS-like algorithm. They don't need any calculation. Only messaging passing is the way to generate a block. And they, like in the real world, they can make consensus committees. And if the committees send their message to make an agree, the consensus, it is over. They do not need any calculation or GPUs. So you will see soon the POS-based blockchain system.
Can I just follow that up and ask, is it possible that Bitcoin can change or adapt the foundation that their cryptocurrency system is based on? I'm sorry, I don't mean to ask such difficult questions.
Yes. In Bitcoin, where I can only say in terms of technology.
Okay.
Yes, in terms of technology, Bitcoin, Ethereum, all of there are an important application for blockchain. I think that is the only thing I can say in this seminar.
Okay, I appreciate that. Thank you so much and feel better soon.
Thank you.
All right, so any questions? Any more questions? So I think if we use Bitcoin, then we don't have to exchange the rate, right? So the money is unified all over the world. So there will be, kind of a good thing that the Bitcoin will bring. All right. So no more questions?
I have a question.
Yes, please.
Yeah, sorry. So thank you, Professor Park, for the lecture. Very interesting. I'm not really informed about Bitcoin and blockchain before. So maybe my question is very basic. According to your lecture, it seems like the blockchain is really safe, but why with the controversy surrounding it? Like a lot of government also have concern about the safety, about it being manipulated. So is it like two different things, the system and also how people use it? Can you please
Okay,
explain? Thank you.
very good question. So basically, technically, the blockchain system is really safe and really trustful, but it requires larger participants. So in case of Bitcoin blockchain or Ethereum blockchain, they are really safe. But there are larger blocks in the exchange. Maybe I heard that there are more than 5,000 coins are exchanged in the exchange service. That kind of blockchain is not safe because the participants is not so many, so they can easily manipulate their data. So that is one reason. And also, as Professor Kim said, the government, I think the government cannot control the currency if the currency is in the blockchain. So it could be a burden for a government. So I think the government should control their currency system using the central bank, but it is not possible anymore if all human uses the blockchain-based system, because the blockchain it does not have any central point. It is decentralized system. So I think the government does not like that system.
I see. Okay. Thank you very much, Professor Park. I hope you get well soon.
All right, thank you. So I think we don't have enough time for more questions. So I think it's the time to finish the first talk. So Professor Park, thank you again joining us. So even though you're not in a good condition.
Thank you very much, and I'm so sorry.
So you may leave anytime you want. Okay, thank you.
Okay, thank you.
So let's move on to the second talk. So which will be taken by Professor Jelarem Jembri Yalu, who is working with me in the same department of KEIMYUNG University, Department of Electronic Engineering. So his name is quite long. So he is from Ethiopia, and he has expertise in communication technology. So I asked him to make a presentation of 5G communication technology and IoT, Internet of Things technology. So, all right. So, Z, you ready?
Yes.
That's good. You can start with your presentation. Okay, thank you.
All right. So can you see my shared slides?
Yes, you can.
All right. Okay then, good morning everyone. My name is Yalo Zelalem Jumbre, but mostly people call me Z because my name is too long. I'm currently an assistant professor at KEIMYUNG University, and I prepared this slide together with Professor Kim Bom-jun. You already met him. So today we'll talk about Internet of Things within the context of 5G. Okay. So first we'll talk about the history of 1G to 4G. Then we'll talk about 5G, what is Internet of Things, and some of the technologies that will allow us to implement Internet of Things. Let me say a few words about myself before I go ahead and talk about Internet of Things. I studied my bachelor's in Addis Ababa, Ethiopia. Then I worked for ZTE as a telecom engineer. Then I moved to Korea, Jeju University, to pursue my master's and PhD. And then I followed that by joining Kyungbuk University. And finally, currently, I'm working at KEIMYUNG University as an assistant professor. My research area is cognitive radio networks and multi-hop wireless networks, mostly these days on multi-hop wireless networks. Multi-hop means that the data should go from one point to another point by traveling through multiple devices instead of just a single antenna or tower. Anyway, so this is about me. We can now start our talk on 5G and IoT. Okay, so we all know that humans have tried to communicate their good news, bad news, and information since the beginning of civilization. So we used to communicate with one another through smoke signals, but we improved to pigeon carriers and so on and on and on. Currently, we have mobile devices that will allow us to communicate. So after actually this telephone communication, we started numbering the standards. So we had 5G, which started with 1G. So what is 5G? 5G is the next generation mobile networks. Actually, it's no longer next generation because most companies and operators start rolling out 5G. And in academy and industry, we started talking about 6G. So currently, most of you are familiar with 4G. So what happens in these generations? Okay, at first, we only were interested in transmitting voice. Then we talked we improved that to digital voice and simple data. When we say simple data, we're talking about texts, okay? So texts take very low bandwidth and low technology in order to transmit from one place to another. Then we started with 3G, which is mobile broadband communication. Currently, we're talking about mobile internet, which allows more applications and faster communication. And you can see that all the communication from 1G to 4G are human-centered communication. That means that will allow one human to communicate with another human being. So what can we expect in 5G? In 5G, we expect a much faster communication, and we expect thousands, if not millions of devices, billions of devices actually connected to the internet. We want to support highly, quickly moving devices, and we want it to be very reliable. And also we want it to be energy efficient, because the communication networks that we are using thus far were not energy efficient, which could contribute to climate change. And also communication is no longer human centered. It's also talking about things. Here is the comparison of requirements between 4G and 5G. I will talk about the couple of them as an example. For instance, we used to support, a device or a car or a train that used to travel at 350 kilometers per hour. But in the 5G, we want to support a device that travels up to 500 kilometers per hour. And also, for instance, in terms of delay or latency, we are currently supporting devices with up to 10 milliseconds delay, but we no longer want that in 5G. We want to make sure that there is the delay or the latency is below 1 millisecond. Okay, so in order to achieve these requirements, researchers and industries such as Huawei and leading researchers Ericsson, Qualcomm, they are thinking of new technologies. Okay, we call them enablers. So the first thing is the use of millimeter wave. So in the early days, we used to not use the millimeter waves, which is the wide band. We used to only use the narrow band. So we are moving from narrow band to wide band in order to transmit more data. We have new channel coding, we have network slicing. Instead of all devices sharing the same network or the same bandwidth, we are now slicing or separating different applications into different slice of the network so that each can be supported. Okay, and we talk about now very massive multiple input and multiple output devices. So you can see that we have our tower, and it can support multiple devices transmitting and receiving at the same time. And as I have said, we are going to support massive connectivity for Internet of Things. And instead of fetching data from the main server, we can store it close to the user, and we can reply from here instead of from the server. So these are some of the technologies that will allow us achieve those requirements. Here is actually what is possible in 5G. As I have said, it's no longer human-centered communication. So we have vehicular communications, we have AR and virtual reality and augmented reality communications, and all of them have different sets of requirements. We can talk about each sector separately for hours, but today I'm going to talk about this part, mostly focus on MMTC, which is massive machine type communication, or what we sometimes call Internet of Things. So I will continue my talk on Internet of Things. Initially, as Internet of Things, actually, we have the RFIDs based Internet of Things. These are the devices such as your bus card, and you went on to the bus and you make like you put it closer to the payment, and it will be able to deduct money. And it was just two devices talking to one another. They were not connected to the internet. So we had RFID based communication. But later we started seeing wireless sensor networks, which can sense their environment and react to their environment. And these devices use Bluetooth for communication. So this was just the history of how Internet of Things, or device to device or thing to thing communication. We have two definitions for Internet of Things from two standard setting institutions. The first one is IEEE, and in IEEE, the main focus is that these are devices embedded with sensors, which means that has sensors, and they are connected to the internet. However, the International Telecom Unit define IoT as a global infrastructure, just similar to airplane route, or similar to telecommunications, similar to road infrastructure. It's just or storage infrastructure. It's just an infrastructure which interconnect things and which allow these things to exchange information between one another. Okay, so when we say Internet of Things, what are things? Because we have to understand these things in order to be able to connect them to the internet. So when we are saying things are, it could be real, tangible, or it could be digital, intangible device, which exists and it also moves in space or time. But this behavior should also be identified. it can be identified by some kind of identification number, by name or location. And we call these things sometimes smart objects, smart devices, or just nodes. And there are 3 categories of these things. We have the passive things, and we have the active things and autonomous things. Usually autonomous things do not require any human controller in order to talk to one another. Okay, and these things can help people connect with the internet. So maybe you have some heart monitor. It will sense your activity, and you have some motion monitors, and they can directly talk to your phone, and your phone can directly talk to the internet and to the hospital. And if there is some problem, maybe an ambulance can be sent. So this is people connected with things. But we can have things connecting to things as well. So you can have some car or vehicle talking to another car, or it can talk to infrastructure such as gas station, or it can talk to just a repair station or to the police. Okay, these are things connected to things. Maybe in 6G, we'll have actually internet of everything. So there is no internet, there is no internet of things. It will just be internet of everything. In order to have internet of things, we first need some enabling technologies. That means technologies that should be mastered or available before the internet of things is talked about. So we need mobile devices, we need data storage and processing centers. The reason is these billions of devices are going to produce tons of data, which we'll discuss later on. We need IP address revolution or evolution, because we need to identify, as I said, billions, if not trillions of devices. So currently only we have to identify human mobiles, human laptops. So it was easier, but now the things, every sensor might need an IP address. So we need to move from IPv6 to IPv4 to IPv6, I think. We need unfettered access to the internet. That means the devices or the things should have 24/7 internet access. And we also need some medium scale and small scale computing systems. That means we need devices, small devices that are capable of computing, and big devices that will help the small devices when the data is too difficult to compute. Here is the architecture or the basic architecture of Internet of Things. First, we have the sensing and identification of the phenomena, and this information or the data that is gathered by sensors and RFIDs, it will be communicated to the information processing via the network, and then this data will be processed, and this available data can be used in many different applications. And here is actually a detail of this architecture. So we have multiple sensors or wireless sensor networks, or we may have some vehicular networks. They communicate with one another. And if it is real-time traffic, okay, if it is real-time traffic, and if the data is simple, we can compute it via mixed computing. That means at the device level, or 2 or 3 devices communicating one another. As the data get complexer, we can start talking about roof computing. We can start talking about edge computing. Edge computing means that the cell towers, they will have computing capability that is better than the sensor and the vehicular devices. Then we can talk about fog computing, and finally you all are familiar with the term cloud computing. When the data is too big, we need massive servers communicating one another. Actually, this might change to blockchain-based computing, actually, because of distributed computing. And I think you have some information about that from the previous lecture. But this type of control or traditional computing is not enough for Internet of Things. We need actually cognitive IoT systems and cognitive computing. That means devices that are capable of understanding their environment, such as pattern recognition, machine vision, and machine learning. So devices should also have some artificial intelligence capability, because they are going to interact with each other and with with humans. So Internet of Things is a new paradigm. It requires actually new paradigm of computing as well. It's going to be one of the biggest market in the coming future, as we'll talk later. Now we can talk about what technologies allows us to practice and to implement Internet of Things. So if you are interested in Internet of Things, you can take a look at some of the devices. Most of you, I think, are familiar or have heard of Arduino, or you have heard of Raspberry Pi. These are actually small computing devices that will process just very small data. So you can buy them. In fact, they are also virtually available. You can go and practice with them. And you can use some board connections as the following breadboard in order to sense some data and display it here. So by doing such things, you can allow yourselves to practice Internet of Things. It seems a little complicated and a little difficult at first glance, but doing this is a very, very simple task, and anyone can learn from it. And there are plenty of tutorials online on YouTube. And I really suggest that you spend maybe $100 or $50 in order to be able to acquaint yourself with Internet of Things, because after 5 to 10 years, or it will be everywhere, and you'll be forced to understand these things no matter what. So these devices are actually equipped with some sensors and actuators. So sensors will allow us to understand the environment, and actuators allows us to talk to the environment, to talk back to the environment. And there are plenty of sensor devices on the market that will allow you to sense light, motion, sound. So you can see that there are plenty of devices or plenty of sensors. These, when you look at them, they look big, but they are just maybe lower than your smallest thumb. So these are very small devices, okay? And these devices will be mounted on the boards such as Raspberry Pi or Arduino that we have already talked about. And they talk to one another via protocols, okay? Me and you can talk to via English, and sometimes other people can talk to via Korean, right? So we have a language for us to understand one another. And for Internet of Things, or for Internet in general, we have protocols, okay? These are some of the rules and laws of communication. Who transmits first, who is responsible for processing data. So these things are governed by the protocols. We can call it actually just the communication language between devices. And for Internet of Things, we have 4 famous protocols. Since we have multiple languages, so we can talk in English, Korean, French, right? So Internet of Things have multiple languages as well. And different language can be used for different purpose. So here are some of the famous communication language that we can use for Internet of Things. Another thing that is highly associated with Internet of Things is data. As I have said, we are going to produce huge amount of data. And this huge amount of data should be processed in some kind of hierarchy, okay? So we can convert the architecture we have already seen earlier into a data management aspect or architecture. Think of it this way, okay? When you build or when we think of some building, we can see it from civil engineering perspective, or we can see it from electrical engineering perspective, okay? So the architecture, we can think of it from communication point of view, and we can think of it from data point of view. So when we see it from different perspective, it has different characteristics and behaviors, okay? So first, actually, we have the raw data from industry and people, and then this data is communicated. Then here, actually, the middle layer, the data management, like filtering, combining the data, and then also storing the data. And then finally, this data will be used by the application layer. What should we do, or what should we tackle when we think of data in Internet of Things? So the first is we have to understand the data source, okay? What do we mean by data source? Like, where do we get this data? Maybe in the mountains, in the buildings, and then we have to collect this data, but every data is not important. So we have to filter this data, and some data need to be combined or fused. So we have to combine the data that is collected from the different places. For instance, for weather prediction, we may have sensors in different universities. For instance, in Daegu, we can have sensors at KF-KEIMYUNG University, Gyeongbuk University. We can have sensors at Yungnam University, and then we can collect this data in order to predict the weather. So prediction can be done via processing. Then we have to store or archive the data. Finally, we have to deliver this information to the user via application. However, when we are dealing with all this data, we have to also think about security and privacy, because someone can hack or can attack our data centers and can steal sensitive information, which could lead to bad outcome. So we have to think about security while thinking about data as well. Okay, now that you are familiar with what is IoT and what are the technologies and what are the aspects of our IoT, it's time to talk about the application perspective of IoT. Okay, so what are the applications of IoT, right? There are actually several applications to IoT, but we'll talk about some of them here. So here is actually a list of applications, but let's only talk about a few of them, which are going to be very prevalent in the future. The first is actually smart home. That is to automate or to enable your homes to be smarter. Okay, So you want to control your home attributes such as the lighting, the AC or entertainment systems. And why do we need smart homes? Because they can reduce energy wastage, they can increase the quality and the reliability of the device, because you don't have to turn on the device from noon to evening. Whenever you want to go home, you can easily turn on your device via a smartphone. Okay, and also smart homes allows us to secure our homes. Or another application is smart grid, where power is gathered at a central location from different sources, and it is distributed to the city. Okay, and this will allow us to deliver sustainable and economical and secure electricity to the community and to our cities. The next application we can see IoT in is smart farms. These days, actually, we are also talking about vertical farms and urban farming, where people farm in their homes, in their backyards, right? So they can allow us, or Internet of Things can allow us to improve farming. So we have sensors, for instance, that can sense the humidity, the soil condition, and other conditions. And they will communicate this via a network, and we can easily, take a look at the data from our smartphone and computers, and we will make some decisions. What are the benefits of smart farms? They can maximize harvest. They can reduce operational costs. That means you don't have to travel, or you don't have to monitor in person all the time. And they can also reduce pollution. Okay. Next, we have smart factories. These are devices talking to another devices in order to produce some product. Okay, but we can also think of 3D or three-dimensional products, which will allow us to produce personalized materials. These days we produce massive things because we want to reduce cost, but in the future we can have products that are specific to one person, and IoT can help with that. And we can also produce short volume products. And another application is where we see Internet of Things is in smart wearables, where devices are worn in our hands, such as in a ring, for instance, in our shoes, in our belts, and they communicate with one another, maybe to give us some information. Okay, and they can help us track people's health and exercise progress. And also we can use this wearable device in health and wellness applications. Okay, we can have these wearable devices on our body, and they sense and transmit data to the internet. And if there is some condition that is severe, we can get an ambulance to our homes, or we can, in the future, smart robots can come and visit our homes in order to be able to help our well-being. Together, all these applications can be combined in a smart city, okay, where all of the IoT services are applied to different areas of the urban settings. And you can see that we can have IoT in industry, medical, building, transportation, agriculture, energy, and logistic, everywhere. And they will help us efficiently use the public resource, and they can also reduce operation cost, and they can help for providing safety from car accidents, because our transportations will be connected to one another via IoT as well. Now that you understand the applications of IoT, let's talk about money, okay? So take a look at this prediction of the market share of IoT, okay? So at the beginning, we have actually PCs and smartphones, maybe same as like same market share, but recently you can see that in 2018, especially like this is up to 2018, but we are now in 2021, this gap is even larger. So we have actually about 30 billion, not 30 million, actually 30 billion devices connected to the internet, which means that we need people to maintain these devices, to install these devices, to monitor these devices. So it's a huge industry that is going to disrupt the whole civilization. So it's best to equip or to have knowledge of Internet of Things. Now we can talk about what other countries and what the world is doing in order to enable IoT. So we are going to consider what is the current status of Korea. And one of the main things for IoT is connectivity. So all the three major operators in Korea have rolled out 5G. That means we can start the process of implementing Internet of Things. It's not as acceptable as 4G is. And this is the 4G availability currently, because we are currently using 4G. And the pandemic also disrupted the rollout of 5G. So maybe we'll see full-fledged 5G in the coming 2 years. But right now you can see that the Korea has almost 100% availability of 4G, but 5G will be the same. And compared to the rest of civilized nations, that is a really high number. And we have another measure for availability of internet in Korea, which will actually facilitate, as I have said, the implementation of Internet of Things. And you can see that Korea is almost one of the first nations, or ranked #1 in terms of download and upload speed. So I think I can say that we are ready for Internet of Things and the implementation of its applications, which we will see in the next, I think, 5 to 10 years. Probably in 2025, I'm sure we are going to be living in the era of Internet of Things. So that's all I can say about Internet of Things. Let me do a conclusion, and we'll stop this talk. So from 1G to 4G, we talk about voice and internet, basically human-based communication. And in 5G, actually, we started beyond human communication, and we have several applications such as vehicular to vehicular communication, Internet of Things, virtual reality and augmented reality communications. We're going to have massive devices, very low delay requirement. This is what we expect with 5G and IoT. And why do we need to understand about Internet of Things and 5G? Because we are interested and we want to work in the future, and we want to create business of the future. Actually, when you think of new businesses, you can incorporate Internet of Things into it. so that you can have competitive edge actually, and also a very high paying jobs are in the horizon. So if you are old enough and if you have kids, it's best to enroll them in this kind of like in Internet of Things boot camps. And if you are young enough to learn new technology, I recommend that you study it and understand it, because it will make you rich. So that will be my talk. And if you have any question, you're welcome to shoot.
All right, thank you, Z. So you provide a excellent, starting point of understanding the communication technology around us. So yeah. So if you have any question, please, please ask us. Thank you. Text. So Z, can you read it, the message?
Let me see.
Yeah. Okay, so you.
Okay, there is.
Okay, so you may answer first.
Okay,
Go
okay.
ahead.
So this is from a health perspective, actually, with the dense network, and there is a fear that 5G or 6G will impact our health, but the amount of power that is released from these technologies is too small to affect our health. So there is just a conspiracy currently going on, and I don't think from 1G to 4G, even like the technology we used in 1G or first generation, they are more dangerous to our health than the technology we are currently using. And from reading about it and from researches done by the medical community, there is no direct correlation that associates 5G and 6G technology to any illness or to any effect to the community. This is as far as I am concerned, but maybe after the implementation of it, there might be some issues, but so far, I think there is no problem. Any other question? Okay, that's a good question, actually. How secured and reliable are Internet of Things application against cyber attacks? Currently, they are not that secure and that reliable. I'll tell you why they are not secure and reliable. Because most IoTs that are currently available use Bluetooth, and Bluetooth is one of the most unsecure technology. So I cannot guarantee that IoT is that secure. But from blockchain, like currently people are using blockchain that we have already heard the talk about. People are using blockchain in order to secure Internet of Things and in general in the internet. And with that technology, I think we can say that it will get better, because even our internet is not that secured. So I think cryptography and blockchain will change that in the future. But at this point in time, yeah, they are not that secured and reliable. Next question.
So people here can ask a question in Korean also.
Now, if you are speaking Korean, you can ask and I will ask for translation and answer in English. All right? Okay, so here is from Curry Daniel. You talked about the delay rolling out 5G in South Korea due to COVID-19 pandemic. Korea is obviously technology advanced in the structure available in countries like Ethiopia to support 5G. Are there plans to improve? Yeah, in third world countries, we are currently, as far as I'm concerned, Ethiopia finished its 4G rollout maybe last month or a couple of months ago. So we are still rolling out 4G and in third world, let alone in third world countries, but in countries such as United States, I think the rollout of 5G and Internet of Things is going to take some time. Korea is small and densely populated, so it's easier to roll out, like the same with Japan. And in China, they have huge amount of investment towards to it, so that is available here. But yeah, in large countries and in developing countries, it's going to be very difficult. Next questions.
So somebody who can speak, who can ask a question in Korean?
You can ask about anything if you are interested. By the way, you can ask about the internet, networking that we have mentioned at the beginning of the talk.
Oh,
all right.
It's not only the Korean people who feel shy in asking questions.
Yeah, I think so.
Okay, then can we finish,
Yeah.
Professor Han? So yeah, okay. This is we in the session we had 2 talks about the current technologies. So I think we try to deliver our general understanding about this technology. So we didn't have enough information about your background. So I'd like to thank all the people participating here, even in morning or weekend. So I hope this talk will help you and provide some understanding. All right. So I hope everybody here have a nice weekend and nice memory while you're staying Korean. All right. Thank you very much.
감사합니다.
감사합니다. 주말 잘 보내세요.
감사합니다.
아직 끝난 게 아닙니다. 그 공지사항이 있어서 공지사항에 대해서 말씀을 드릴게요. 지금 제가 한국어로 이야기를 하니까 아마 Translation English 버전으로 들으시면 될 것 같습니다. 다름이 아니라 저희가 이메일로도 지난번에 말씀을 드렸는데 이제 필드 트립과 관련된 안내를 해드렸습니다. 그래서 1차로 모집을 완료했는데 이제 추가적으로 더 진행을 할 수강생들이 있으시면 10월 이제 말이 되겠죠. 10월과 11월에 모두 진행을 하셔도 됩니다. 그래서 필드 트립을 계속해서 이제 신청을 하실 분들은 이메일로 뭐 간단한 계획서를 보내주시면 될 것 같고요. 그다음에 10월 30일에 저희가 공공외교 주간이 있으면서 첫 번째 필드 트립 발표회가 있습니다. 그래서 지금 수강하시는 B 세션, C 세션 모든 이제 A 세션도 마찬가지고요. 완료된 모든 학생들이 들어오셔서 같이 관련된 이야기도 나누고 경험도 이제 공유하면서 좋은 시간을 보냈으면 좋겠습니다. 그래서 10월 30일에도 이제 줌 세션이 열리니까 줌으로 많은 참여를 부탁을 드리고 그다음에 필드 트립과 관련해서도 필드 필드 트립을 하실 때 이제 하루에 지원비가 4만 원씩이 지원이 되고 최대 3일 지원이 됩니다. 그래서 지원비도 드리고, 그다음에 그 공공외교 주간에 발표를 하러 오시는 분들께도 이제 서울 경기에서 오시는 분들을 제외하고는 모두 교통비가 지급이 됩니다. 그래서 참여하셔서 직접 필드 트립 하셨던 이야기도 나누시고, 그다음에 멕시코 대사님이 진행을 해주십니다. 그래서 멕시코 대사님과 관련한 이제 뭐 공공외교라든지 민간 외교라든지 관련된 정보도 공유하고, 그다음에 이 수업에 들은 다른 참가자분들하고도 이제 교류를 위해서 많은 분들이 참여를 해주셨으면 좋겠습니다. 그래서 이와 관련된 내용도 언제든지 저희 그 KF 관련된 이메일 아실 겁니다. 그래서 이메일로 질의응답을 해주시면 되겠습니다. 오늘 주말 오전에 시간 내주셔서 감사하고, 다음 토요일 오전에도 같은 시간에 같은 주소 이 회의창을 통해서 세 번째 강의가 진행이 될 거고, 다음 시간에는 이제 여러분들이 아마도 굉장히 재미있는 시간이 되지 않을까 싶습니다. 이제 한국의 요리, 음식에 대해서 이제 역사와 기원과 관련된 뭐 조리법이라든지 이런 것도 이야기를 해주실 겁니다. 그래서 다음 토요일에도 여러분들이 빠지지 않고 모든 수강생들이 참여를 했으면 좋겠습니다. 이외에도 관련된 질문이 있으시면 언제든지 이메일을 주시면 저희가 빠르게 답변을 해드리도록 하겠습니다. 오늘 많은 참여를 해주셔서 감사드리고, 언제나 적극적으로 수업에 참여를 해주셔서 감사합니다. 수고 많이 하셨습니다.